last 25 years of research, people, among which many people in this room today, have shown that infant cognition is very rich. And in fact, infants engage in all sorts of reasonings. So they are capable of reasoning about the rationality of actions, inferring, for instance, the presence of an obstacle that is so far invisible. They're capable of representing different possibilities and engage in probabilistic reasoning, in some kind of elementary logical reasoning. They're also capable of forming hypotheses to account for surprising events, and they act as if they're directly testing these hypotheses. They are capable of reasoning about others' beliefs and state of knowledge, and they might have also even some kind of moral sense. So all of these results and many others suggest that it forwards the idea that there is a large continuity between infant cognition and adult cognition. And an appealing way to account for all of these results, and again many others, is this idea that infants might be equipped, just like adults, with a certain kind of language of thought. So the language of thought hypothesis, in a nutshell, is this idea that non-linguistic thought might have a similar structure as natural language. In other words, it has discrete symbols that can be combined to form propositions, just like we combine words to form sentences in natural language. And in fact, of course, this idea got very popular in cognitive science with the work of Jerry Fodor. And in Jerry Fodor's writing, there is also this idea that the language of thought, in fact, precedes natural language. So there's this idea that, in fact, language has the properties that it has because it's a kind of translation of the language of thought. So these kind of observations motivate a research program that was largely initiated by Luca Bonatti and some of his collaborators, Niccolò Cesana-Arlotti, Ernest Teglasch, Anna Martin, and others. So the research program to look for language-like structures in pre-linguistic young infants. And so this is what this symposium is largely about. And in the work that I'm going to present now, I'm trying to ask about one of a fundamental aspect I'm looking for, so a fundamental aspect of language is that words are combined in a systematic way. They're combined according to the roles that they play, to the syntactic or semantic roles that they play in the sentence. So what could that translate into for non-linguistic thought? So I'm going to ask whether infants have some kind of structured representation of events where they can mark the different actors with some thematic roles. And we start with probably the most basic role, that is agent and patient. So to exemplify this, take those two images. Both images depict a little boy, let's name him Charlie, and a dog. And both images also depict the action of biting. But of course, there's a crucial difference between those two images. That is, on the left one, Charlie is the one that is bitten, whereas on the right one, he's the one that is biting. Right? So in other words, on the left picture, Charlie is the patient of the action. On the right one is the agent of the action. So those thematic roles, agent and patient, distinguish the crucial difference between those two images. And these roles are abstract in the sense that we can recognize that there is a similar structure in these three events here, where you see Charlie kissing a girl, Charlie hitting a child, and again Charlie biting a dog. In those three actions, despite the fact that Charlie is using a different effector, so he can use his lips, his hand, or his teeth. He can have good intention, bad intention, and again, there are a lot of differences between these three actions, but there is something that is common, is that on all of these three actions, he has a similar role, that is the role of the agent in the action. So we're asking whether infants are capable of representing this kind of similar structure in those type of events, and on what basis they do this. So what are the perceptual cues that they can use to recognize the agent and the patient of an action? Very recently, there's been some work, particularly by Alan Hafrey and his colleagues, and we've done similar things with Sophie Vettori and Luba Papeo, that showed that if you show an event like this one with two actors, the agent is recognized as the one that is leaning forward and maybe has outstretched limbs, whereas the patient tend to have a more neutral position or maybe even leaning backward, and the limbs tend to be closer to the body. So the hypothesis we're testing here is that infants can assign roles of agent and patient on the basis of this type of cues, that is on the basis of body posture. So the prediction would be that when we change postures, the saliency of posture change should be stronger when this change of posture also triggers a change of role. So as long as you change but you remain in an agent-like posture, that should not be too much salient, but now if you change from an agent-like to a patient-like, that should be more salient. The second prediction is that derived from the idea that roles are relational representation. That is, the agent is acting on the patient and the patient is acted upon by the agent. So that triggers the prediction that agent and patient should be assigned better when the two actors are in one event, so when they are in an interaction rather than when they're not. So to test this, we've run this first experiment in a habituation-dishabituation study. So we presenting 7-month-old babies with this type of images. During the habituation, you can see that the blue boy is always in an agent-like posture, that is, leaning a little bit forward with outstretched limbs, and the orange girl here tend to be in a more patient-like position. But the postures of both of the actors are changing in every image. After habituation, we go to the test trials, and there are two types of test trials. In both test trials, we show novel postures, but the postures can respect the same type of posture, so the same roles. So that's the same role trial type, where the boy is in a novel posture, but again, agent-like, and the girl is in a novel posture, but again, patient-like. And in the role switch trial, we swap the roles, so now the boy is in a patient-like posture and the girl in an agent-like posture. And what we can observe is an increase of looking time for the role switch trials with respect to the same role trials, which suggests, as predicted, that babies, that the role switch change of posture were more salient than the same role change of posture. Now, the second prediction, again, was that this process here should be working much better when the two bodies are in interaction than when they're not. So to test this, we ran a second group of babies with exactly the same stimuli, but now the two bodies are placed back-to-back instead of face-to-face. So this is what it looked like. So you have exactly the same posture and posture changes, but now the two bodies are back-to-back, so they're not really in a position to interact. And what you can see is that, as predicted, the effect disappeared in this situation. So this shows that the effect that we observed in the face-to-face group is not due just to some kind of categorization of postures are more or less dynamic, but rather the effect reflects the representation of a relational structure where the two actors and their postures are interpreted with respect to one another. Next, we replicated in a second experiment the previous results, but with a different technique. So now, instead of using looking time and a habituation study, we're using a noteball paradigm, and we're looking at pupil dilation. So here we're presenting, again, sequences of images. Each is presented for 3 seconds. And again, in most of the images, so in the standard images, the blue boy is in the agent-like position. And in the deviant images, that is 1 out of 6, it's the girl that is now the agent, and the boy is the patient. And we observe pupil dilation, which is reflecting surprise or increase of attention in the deviant trials with respect to the standard trials. So again, that replicates the previous result, that babies notice particularly this change of postures. And again, when we place the bodies back-to-back, same posture changes, but this time they are not triggering any pupil dilation. So finally, in the last experiment, so far we've looked at body posture as the main cue to identify the agent and patient, but there are other cues that can identify the agent and patient. Take, for instance, this scene. So on the right, who thinks that the boy is still, again, the agent? So please raise your hand if you think the boy is the agent. Okay, raise your hand if you think it's the girl. Okay, not much participation, I would say. So you should think that the boy is the agent and the girl is the patient. If you think that, of course, you cannot have made this decision based on the posture of the two characters because they actually have the exact same posture, right? They are both in a neutral, passive posture. But the boy is oriented toward the girl, so he's in a position where he can act on the girl, whereas the girl is looking away from the boy, so she cannot really, she doesn't have access to the boy. So the idea is that if the structure, the relational structure that we've talked about so far, about agent and patient, is abstract, it should be independent from the actual cue that you're using to recognize who's the agent and who's the patient. So the representation that you might infer from this type of scenes on the basis of posture should generalize to that type of scene on the basis of relative position. So this is exactly what we're testing here. So this is again an oddball paradigm with pupil dilation. The standard trials are exactly the same as in the previous experiment in the face-to-face condition, right? So in the standard trials, you see the blue boy in an agent-like posture and the orange girl in a patient-like posture. But now we have two types of deviant trials. In both deviant trials, the postures are the same. It's two neutral postures. But in the same role deviant trial, the boy is oriented toward the girl, so he's still in the same agent position. But in the role switch deviant trials, it's now the girl that is oriented toward the boy that faces away. So here, the boy cannot act anymore, so there is a change in the role assignment. And we observed a dilation of pupil that was stronger in the role switch deviant trials than in the same role deviant trials. So this shows that infants equated the structure that they inferred from the relative posture, who faces whom, in those deviant trials, with the structure that they inferred from the relative posture in the standard trial, that is, who's more active and who's less active. So both cues, posture and position, seem to be used to fit the same abstract relational structure that we can describe in terms of agent and patient. So to conclude, we've shown that young pre-lexical infants at 7 months have a structured representation of events, marking who acts on whom. And those representations of agent and patient are relational. They are particularly activated when two characters are in an interaction, when they're face-to-face and not when they're back-to-back. Those representations are abstract. They're abstract in two senses. The first sense is that they generalize to different postures, so to different actions that you would maybe name differently. Some might be kicking, some might be kissing, some might be talking, some might be pointing at. And they generalize also to different cues, so you can generalize from posture cue to the position cue. Finally, I want to note that there are recent findings that are convergent with this in non-human primates, which strengthen the point that this type of representation is independent or at least precedes language acquisition. And again, we focus here on the most basic role, that is agent and patient. But when you think about the literature on infant cognition, there are many data that points at other roles, such as goal, instrument, cause, recipient. So I think one interesting path for future research is to try to understand how much of the data we can explain, we can account for by playing with these roles assigned to different individuals. And finally, to conclude, the purpose of this talk was to show evidence for one crucial building block of the language of thought, that is the representation of thematic roles, but that by no means necessarily mean that language of thought is complete in young infants. I've started this talk by noting that there is some data suggesting a large continuity between infant and adult cognition. There are also some data that suggest some discontinuity along development. And so we might think that maybe some component of the language, some building blocks are present early to account for some continuity, and we need to think also what kind of building blocks might be missing and could account for some discontinuity. So that's the matter maybe for future work. I thank you for your attention. I want to thank also, of course, my co-authors. So this is a collaboration with Liuba Papeo and also with Sophie Vettori, Catherine Audin, Émilie Serrail, and Farzad Rostami. Thank you very much.
Okay, we have 5 minutes for questions.
Thank you. I'm here. So I'm just trying to understand something about the logic of these studies. So it seems to me that agents and patients are properties or like roles in a sentence, not really in an event, right? Like I can have one event and I can describe that event with either parties being agents and patients. So for in a launching event, if A launches B, then B is blocking A. Right? So it seems that sentences doesn't enforce any sort of roles in the way that your events seem to enforce on the interpreter. Sentences would be okay basically with another type of vocabulary. You can describe the same event as the other party being the agent or the patient. So I'm just wondering, I have the same effect as you. I see one of the parties as being a doer and the other party is more passive, but I don't know how it relates to the linguistic notion of agent and patient that can go either way here.
So, I mean, well, so if we start from language, right, the fact that you have agent and patient roles that you can see in the sense that it has some impact on syntactic rules or the way you form sentences in general, right? And independently from then the actual action that will be named by the verb. Let's put it this way. And so what we're trying to show here, and I think what the data suggest, is that there is something like that in infant man. So just think, what if you were to name these actions, right? So this one you might want to name kicking, maybe this one you will name punching, this one you might name as pointing, etc. So they all have different meaning, if you want. But what the data suggests is that infants see a common structure in all of those actions. So yeah, call that agent patient. Maybe you can call it doer and I don't know, doey. Or something like that, that's fine. The idea is that this kind of structure then can feed into natural language, and maybe that's where the syntactic notion of agent-patient would come from.
Thank you. Other questions?
A somewhat related question. So I'm finding a bit of a tension here between trying to identify knowledge of something very abstract in these roles in infants and grounding the events in something so physical, right? Because agents and patients have nothing really to do with physical actions because the boy is ignoring the girl is a very agentive act, right? And it's not represented in body postures. So I'm wondering if there is a, at some point, if infants are really sort of cued into the body posture stuff, at some point do they have to shift tax to really get to the non-physical act notions of agent and patient?
Yeah, so you're right. I guess one way to say that is that what we've shown so far applies mainly to physical action. Absolutely. So as I said, there are probably more cues than the ones we've looked at. So we've shown 2 cues already, and it's interesting to see that there is generalization from one cue to another. So that already suggests some kind of abstraction. Then whether there is even more abstraction and more generalization, I guess that's open. Has to be tested. It is true, of course, that, for instance, and I guess maybe that was your intuition. You could say here that the boy is ignoring the girl, right, and therefore he becomes the agent. Absolutely. I guess first of all, probably you need a dynamic scene to see that more well. But you could imagine that that there will be more cues that would pull the attention onto the boy and get this thing. But, yeah.